Let's find the antiderivative of f of x equals 4x cubed. So remember, the antiderivative is a capital F, so we have capital F of x equals, keep the 4 out front, times x to the, remember it's 3 plus 1, so we go up 1 to 4, and then we divide by the new exponent. And oh hey look, these 4's cancel out, that's nice. So the antiderivative is x to the 4th plus c. The c just stands for any constant number. Now we're going to look at some antiderivative rules. The first one is the power rule, and that's what we've been using so far. You raise the power of your original function and then divide by the new exponent. And that's just if you have a simple x to the n situation. Now, we've been doing this but haven't really talked about it that much. The reason we can do it is the constant multiple of the power rule is when you have a number out front, like some sort of constant being multiplied, you can just multiply it times the antiderivative that you're taking. So like that's what we did with the 4. Like pretend 4 is k right here. That's what we did in the brain starter. And the sum and difference rules work exactly as you would expect. If you take the antiderivative of two different functions that are being added together, then you can just add them together, or subtract, same thing. This works really well with polynomials, something along the lines of like the antiderivative of x squared plus 2x minus 3. That way you can just take the derivative of each term by itself and then add or subtract to put it back together again. Alright, let's see them work out. So, the antiderivative here, capital F of x equals, constant, we'll just multiply it. Then we have x to the raise the power from 7 to 8, and then divide by 8. Now, these don't cancel out like they have been, sorry about that. But you can cancel out that and make it a 2. So the antiderivative here is x to the 8th over 2. For the next one, I'm going to rewrite this thing again just to make it easier. We don't want x's in the denominator, it gets confusing. This is 2 times x to the negative 4. Now we can take the antiderivative very easily. So capital F of x equals 2 times x to the negative 4 plus 1 is negative 3, and then you divide by negative 3. So to rewrite this a little cleaner, it's like negative 2/3 x to the negative 3, which if you wanted to make it even more clean, you could do negative 2 over 3x cubed. And the last one, it's a polynomial, so we're going to treat each term separately and then put it all back together again. So the antiderivative of this is, the first term is x to the 3rd divided by 3 minus, we have 8 out front, and then we have x squared over 2, and then plus 5, and here's a little twist here, it's plus 5x. It's essentially like when you took the derivative of something like 5x, you just get rid of the x term. If you just have a constant term, you just add the x back in. And of course, you could justify it with, things of pretending this is like 5x to the 0 and that sort of stuff. Alright, and now to simplify here. We have x to the 3rd over 3 minus, these will cancel to a 4. So we have minus 4x squared plus 5x. And the part that I forgot in every one of these examples, which is going to be crucially important later, is plus c plus c plus c.